Welcome to Grade 12 Electrochemistry. My name is Jeremy. I'm going to be your teacher for this section. I hope these videos will blow your mind as you realize how the simple transfer of electrons is fundamental to a whole branch of chemistry, and how chemists have put this concept to work in a range of technologies that we use every single day. This section will build on the work that you did on redox reactions in grades 10 and 11. We'll start by recapping oxidation numbers, which we're going to use right throughout the section, and then we'll just check in on those definitions for oxidation, reduction, oxidizing agents, and reducing agents. We'll be looking at two different types of cells during this electrochemistry unit. My experience tells me that students sometimes get the two different kinds mixed up. So keep your wits about you, and I have no doubt you'll be one of those smart students who can tell the one from the other. The first type of cell is an electrolytic cell. This is one where we put electrical energy in and we get chemical energy out. Simply put, we attach a cell to some kind of battery pack or power supply, and the electrical energy from that battery then drives a non-spontaneous chemical reaction. The clue to look for here is that an electrolytic cell always has a battery, so look out for it. Once we have a firm grasp of the principles of electrolysis, we're going to look at three fascinating applications of this technology. Firstly, we'll have a look at electroplating and see how we electroplate a silver spoon. We'll then have a look at the electrolysis of brine or saltwater solution to produce chlorine, hydrogen, and sodium hydroxide. And finally, we'll look at how electrolysis is used to purify aluminium from its ore, bauxite. The second kind of cell is called a galvanic cell, or sometimes a voltaic cell. And in this cell, chemical energy is converted into electrical energy. Did you get that? We're going to actually generate electricity. We harness the power of a spontaneous chemical reaction to create a flow of electrons. And of course, what's a flow of electrons? It's just current electricity. The clue in this cell is that you won't see a battery anywhere, because the cell is generating electricity itself. So in place of a battery, you'll see a meter of some kind, a voltmeter or a galvanometer. That's the clue to look out for. Once we have a good grasp of the concepts involved with galvanic cells, we'll then integrate that into the previous work that we've done on rates of reaction and chemical equilibrium. So that's where we're going. It's a fascinating piece of chemistry with very tangible applications into technologies that we experience every day. I think you're going to enjoy it. Let's get going.